everyone, and welcome to the Solid State Watch. I'm Shannon Davis, the web editor for Solid State Technology, and now let's take a look at the top headlines we've been tracking from February 6th through February 12th, 2015. Applied Materials on Wednesday reported that its proposed merger with Tokyo Electron is still underway without giving a deadline or expected date of conclusion. President and CEO Gary Dickerson said that the company is making progress with regulators and plans to complete the merger as soon as possible. He declined to elaborate on that point on the advice of its attorneys. Applied and TEL teams are working together to fulfill the strategic opportunity that this merger creates, Dickerson said. Worldwide silicon wafer area shipments increased 11% in 2014 when compared to 2013 area shipments, according to the Semi-Silicon Manufacturers Group in its year-end analysis of the silicon wafer industry. However, worldwide silicon revenues increased by just 1% in 2014 compared to 2013. Silicon wafer area shipments in 2014 totaled 10,098 million square inches, which is up from the previous year. Revenues totaled $7.6 billion, which is slightly up from $7.5 billion posted in 2013, yet 2014 silicon revenues remain 37% below their peak set in 2007. This week, after a 4-month investigation, the U.S. Department of Commerce declared the export controls on certain etch equipment and technology ineffective, thereby removing a cumbersome impediment to efficient trade. With this positive ruling, SEMI will now work with U.S. officials to decontrol etch equipment and technology at the international level, pushing for removal from multilateral export control. Researchers at the University of Texas at Austin's Cockrell School of Engineering have created the first transistors made of silicene, the world's thinnest silicon material. Their research holds the promise of building dramatically faster, smaller, and more efficient computer chips. Made of a 1-atom thick layer of silicon atoms, silicene has outstanding electrical properties, but has until now proved difficult to work with and produce. To work around these issues, the team developed a new method for fabricating the silicene that reduces its exposure to air. To start, the researchers let a hot vapor of silicon atoms condense into a crystalline block of silver in a vacuum chamber. They then formed a silicon sheet on a thin layer of silver and added a nanometer-thick layer of alumina on top. Because of these protective layers, the team could safely peel it off of its base and transfer its silver side up to an oxidized silicon substrate. They were then able to gently scrape some of the silver to leave behind 2 islands of metal as electrodes with a strip of silicene between them. For more industry headlines during the week, be sure to follow us on Twitter or like us on Facebook. For Solid State Technology Magazine, I'm Shannon Davis. Thanks for watching and see you next week.